the code, so answering your question, if you want to download the full code, you go to energy.california.gov/Title 24. That's where you download the full code. Feel free to do it. If you have free time in your sleepless nights, that will help you fall asleep very easily. And if not, this is the full presentation. I'm not going to show every single slide, but it's available for you guys. It's put together and copyrighted by Wattstocker. Please don't sell it if you download. Or if you sell, let's split the profit or find a way to do it. When it's effective, January 1st, 2014. After the fiasco of the previous Title 24, I don't think the CEC would accept a lower or a longer time to implement Title 24. So we don't expect a delay. It's coming faster than we think. The response that we've been having from specifiers in California is tremendous, and that's been in the last month or 2 months. A lot of specifiers starting to working on how can they implement the Title 24 changes in their drawings, and also their fees and how they're going to work around it. I think for the contractor side, you're going to see all the drawings following those requirements, and you just have to comply. Overview of the sections. Am I moving too? I mean, I'm thinking of the guys filming. Am I still?
You're good.
I'm trying to skip, but I guess I don't have an option.
You're good.
So sections. This presentation will talk more about lighting controls, but they're all different sessions. If you're in the mechanical side, you might want to read more about mechanical requirements. We can touch a little bit of addition and alterations because there are some changes in those areas, residential, but mostly I would cover lighting controls. There's about 45 pages of definitions in the Energy Code. I think the most relevant ones for lighting controls are here. Previous version of Title 24 occupancy sensor. It's a sensor that detects when people are in the space and times out when the room is vacated. Vacancy sensor was a new term that came in the past Title 24, that it's a manual on occupancy sensor. For in a residential application, if you have a huge window, you don't need to automatically turn on the lights. So you allow people to manually turn on the lights, but the lights turn off when the room is vacated. That's a vacancy sensor. There are 3 new definitions in this Title 24. Partial on occupancy sensor, a partial off occupancy sensor, and a part night outdoor lighting control. So those are the high-low sensors. So some areas you're not mandated to turn off the lights completely, but it's mandated to stay in a certain level until somebody steps into that space and then it goes to full level. Some other areas are mandated to stay in a higher level and then drop to 50%, 30%, anywhere from 30 to 70% when those rooms or areas are unoccupied. So you have to pay attention because there are going to be some charts talking about partial on, partial off for warehouse areas and library stacks and parking areas. Those were not in the code before. So those are new requirements. A lighting control system is on Title 24. The components need to be approved by CEC. Most of the manufacturers self-report their products. And as long as you're following the directions and you're following those categories, they are determined in the code. Most manufacturers would have everything in the database. Usually in the beginning of the year, those databases get kind of messed up, so we might have a bunch of products that are not compliant in January 1st, and then January 15th, they all compliant all over again because the database gets lost. Every year it's the same problem. So just keep an eye on using products that are CEC approved. Self-contained devices, some of those Home Depot type of components, the same way that you have with lighting, screw-based LED lamps and some of the lighting controls, because it's so difficult to regulate those, they moved from Title 24, which is the lighting component or the electrical component, to the appliance side of the Energy Code. So now those self-contained devices, time switches, and they have to be listed and approved in the Title 20, which is a different code for appliances. Just a reference here in case you want to know more about some items that you can find in the big boxes. Building codes that apply to, in the first part of the presentation, we will cover commercial and industrial requirements. And those are the sections in lighting controls. 130 used to be 131, 132, 133 was easier to follow. Now it's A, B, C, D, E. There's a brand new one that's demand response. And if you memorize those numbers and letters, they can be helpful because a lot of charts talk, if you have a remodel and depending on the size of your retrofit, you need to follow some requirements. They're not going to say, oh, you have to have auto shut off. They're going to say, oh, you have to follow 130 docs, 1C. So you need to follow C and D for daylighting. So there are some changes on the numbering of the code. First one, basic for lighting controls. We've always been doing that for, I don't know, over 100 years. If there is a space, there has to be a switch to turn on and off the light. That's pretty basic. That's on Title 24. That's what they call area control. It doesn't mean a manual on occupancy sensor. It has every space that has floor to ceiling partitions and that has more than 0.2 watts per square foot, which is kind of impossible to have a space with less than that, need to have a wall switch. You have plenty here. We're complying with codes for the new permits, and that's been in Title 24 for a long time. The bad news or good news for some of you is that it used to be a switch or occupancy sensor. So if there is a multi-stall bathroom and an occupancy sensor turns on and off the lights, that was enough. The code is telling, no, occupancy sensor, it's no longer acceptable to comply with the basic section of Title 24. You have to have a switch. I do not recommend a wall switch in a multi-stall bathroom because you might turn off the lights and somebody's using the bathroom. So you can use maybe a captive key switch in that space. But you still have to use some kind of manual control to allow users not only to turn on, but most importantly to turn off if they think that there's too much light in that space. So it's the manual off that is the most important for Title 24. Not for us, because we like light, but for them, they want to allow you to turn off the lights if you don't have to use those. Some areas like malls, auditoriums, and large conference spaces, the switch doesn't need to be physically in the space as long as there is a pilot light. So a lot of switches that you can find in the industry, they would have a little pilot light, and you can engrave the areas as long as there is a switch for each general lighting control in that space. That's enough, that complies with code. And just a reminder, if there is case lighting or accent lighting or display lighting, those need to be switched separately. Code requires, you cannot have one master switch for everything. In a space like that, I don't even know how to, you guys probably have ways to access every single fixture on its own by using the lighting control system that you chose in this space. But in a regular scenario, we have case lighting and display lighting, probably with wall switches or some kind of point of control located in the space. The second one is multi-level, and that's probably the most polemic one in case right now. Multi-level control used to be A/B switching. We were happy with that. Everybody was used to complying. There are ways to do it with lighting control systems that can do 2 relays, a switch that does 2 buttons, that has two buttons, one for A, one for B, and an occupancy sensor that can override it all. Turn on, turn off, manual on, manual off, you choose it. Now, you have to follow the table 130.1A, and that's the table. And I think every fixture manufacturer from now on would have some kind of interpretation of this table. And probably the most relevant ones are these 2 lines. And I will start with linear, higher than 13 watts fluorescent. A lot of applications, commercial spaces. Before, we were able to do 2 fixture luminaires, right? A, B. So I have 33%, 66%. Actually, I had 33%. With the 2 fixture, I would have 50%, 100%, and 0. With the 3 lamp, I would be able to do both. It's impossible to accomplish that with a 3 lamp fixture now, or a 2 lamp fixture, unless you have a dimming ballast. So low, 20 to 40 with a 3 lamp fixture, I can do it. Medium, 50%, pretty easy. The high level, all between 80 and 85%. And 85% it's a number that's directly related to what the demand response controls are talking about, because you need to drop 15% of your total lighting electrical load in that space. Unless you have a fixture with 4 lamps, there's no way that you do that. And I don't think we're going to see fixtures with 4 lamps and multiple ballasts in projects moving forward. So that's the big one, because dimming costs a lot of money, right? I mean, are there some fixture reps or here in the room? Or you guys sell fixtures, right? I mean, all the rec sell Polo guys. We have situations where continuous dimming is perfect for high-end applications. Customers, when they're used to or they're asking for, they're not too worried about payback. And actually, in order to be on the energy code, you have to prove some kind of return on investment or payback. What do you think it's a doable payback in a commercial space? How many years?
Less than 2.
2 years? Less than 2 years? 3 years? 18 months? Is that a reasonable payback? For the CEC, 15 years is considered a doable payback. It's not me, it's the CEC. So we know that it's very difficult to consider a 15-year payback. Yeah, I mean, and which number do you think they put in the dimming ballast? Which price? How much is the dimming ballast? You guys sell those? $90, $80, $100. They mention in the code about $28. I don't know where they're buying their ballast, but they're not buying any ballast. The idea is, how can I make it so competitive that I give you the whole state of California, hey, dimming ballast manufacturers, you would have the whole state of California, your prices need to drop. So no payback and a very low price. Unfortunately, that's the energy code behind. What I see is that it's going to help a lot of LED sales, because most of the LED drivers, they're already coming 0 to 10 volts or switching, and there's a very slight difference between dimming and non-dimming with LED in terms of price. So I can see, or the industry would see, a lot of lighting projects being accomplished with dimming LEDs. And I think when fluorescence starts losing markets to LED, they might drop the prices of dimming bells. And that's probably what California is envisioning, and that's what's going to happen. I mean, the LED price is so much higher anyway, but there's more efficiency. We are worried about watts per square foot, and with LEDs you're able to accomplish a much lower level in terms of power density, so it's beneficial for your applications. The others I don't think are very relevant, because you can have steps. On top of that, you have to give a manual control. So if auto shut off when room is not occupied, but when I'm in the space, I think I have enough light, I can manually turn off the lights. That's the requirement for Title 24. The new section, brand new section, partial on and off sensors with automatic off. So warehouses, library stacks, it makes sense. During normal hours, those library stacks are not being used. Lights go down to at least 50% of the time, or the electrical power in that specific aisle or in the specific area. If somebody steps in, the lights turn to 100%. So that's the partial on and off. And it's without auto off, so it's not, or with automatic off. So after hours, those lights need to turn off. And that can be done by a time schedule. So by level during the day, off at night. The new area here is corridors and stairwells. So now corridors and stairwells, they used to be exempt from Title 24 auto shut-off requirements. Now you have to do by level and shut off the lights when they're not occupied. So that's a new requirement, and that's going to be a relevant one. Then there's a partial on and off without auto off. So for hotel, motel corridors, and high-rise residential applications, those corridors, they can be just by level. You don't need to shut off the lights. Unoccupied, at least 50%, and occupied, you can go up to 100%. And depending on the areas, you can go up to 80%, depending on the lighting power density of the space. Parking garages were exempt of all of that. Now, with parking garages, you need to go between 20 and 50%, and you don't need to turn off the lights. So parking garages need to have sensors, and those sensors need to control half of those lights. And you cannot have sensors all over the space and just turn on everything per sensor. There's a limit of 500 watts max per sensor. So we will see more fixture-based type of controls in those parking garages. So large parking garages area, they need to have a bi-level control and never turn off. The only areas they are allowed to turn off are daylit areas in the perimeter of the parking garage. That goes in the daylighting requirements. Is that too painful? You guys good? Didn't lose anybody? Some people are going to start leaving. Oh no, I don't want to hear that. Gas rooms, this is nothing new if you go outside anywhere except the United States. There are master switches by the door, and those master switches can be at times, you guys have seen some key card switches. You have your hotel key, you enter a room, you put your key, it's a contact closure, turns on certain lights in the space. When you leave, you hopefully take your key with you, don't leave the extra key over there.
Can I actually ask a question about the parking garage real quick?
Yes.
So, can you do A/B with the, I mean, not A/B, but checkerboard almost to take the fixtures out, or do they have to be bi-level fixtures?
They are trying to make it, because there are some requirements on uniformity. So if your checkerboard does not meet those uniformity levels, which is impossible,
right,
especially in a parking garage, you
okay,
have a very long distance between fixtures because the luminance level is much lower than
I can find.
Sorry.
Read by
And you're
John.
lost. I mean, I don't know, is that a GPS that you are talking or? Sorry. Yeah, so checkerboard is no longer acceptable in pretty much any bi-level application.
Okay.
Because you have to meet those uniformity levels, and it's almost impossible to meet without doing either bi-level or dimming. So it's, that fixture needs to have an A/B quality. And depending on the space, you might have dimming. A/B would not be acceptable. In parking garages, you can do bi-level.
Okay.
Most of the LEDs are ready for bi-level. Most of the sensors, so if you notice here, there's a little sensor, it could be a watt stopper sensor, and that can allow you to do the A/B control. And it's a low voltage sensor powered by the same power of the fixture itself. Can be mounted, there are some OEM, most of the fixture manufacturers have access to those type of sensors. So you can order them with a sensor built in. I don't know if you guys show here examples of fixtures
Yeah, we
that
have
have
more of
sensors. They're probably not mine, so I'm not going to point out. But that's okay, but that one is mine, and it's a great question. It's the most common question. How can we do checkerboard? A lot of applications we used to do that. Now with the uniformity, I don't have the table here, but you can go back to the code, or we can try to find online. It's impossible to meet with checkerboard in parking garages because they get pretty distant.
Procedural question. Same on the parking garage. Do they specify a time limit to when you reduce down?
So the maximum is 30 minutes. So that's, they don't require a minimum time delay, and it's uniformity and light level. That's what they're asking for. The energy code does not allow you to go above 30 minutes. So if the space is unoccupied after 30 minutes, usually depending on where you're trying to, what you're trying to accomplish, you might cut that short. A lot of manufacturers ship their products with a 20 minutes time delay because it's a more cost effective in terms of energy usage in the
Actually,
space.
see 4 minutes a lot.
You can even do longer or shorter. I mean, a lot of features, especially with the LED, there's no time to bring back up. Those happen very, and when you're using multiple sensors and multiple fixtures, you're not going to have a large area that it's in the dark. So the state is mandating more granular solution that you really use a fixture-based type of control, so you don't have those shaded areas. They're all in the limit from that sensor, and try to keep it very constant. So you're walking and almost creating a pathway to your car in that scenario, but it's never less than 20%. We're good. Guest rooms, it's just a good example of mandatory, either use of controls, automatic controls. You can use just a master key switch in the door, by the door. It's not acceptable anymore. The most common would be a lot of manufacturers are starting to bring some key card solutions where you can just turn on and off those lights in those guest rooms. The other one that is fun and interesting because it's a big change, it's daylighting. It's not going to be a fun one for electrical engineers because now you have to trace more of your skylights, you have to really define those in your plans, and you have to hope that they're understandable and will be implemented properly by the contractors. There are three areas that need to be considered: skylit areas, primary side lit, so windows and floor to ceiling or even half height windows, and then secondary daylit area. A skylit area, there's all kinds of calculations, but the basic one is you take the size of the skylight and the window and the ceiling height, and you use 70% of the ceiling height in each side to trace your skylit area. If it's a circular area, you have to match that shape. So the floor shape needs to match the skylight. And it used to be a distance to the permanent obstruction. So if there is a permanent, a stack shelving units in that space, that it's permanent, maybe in a warehouse scenario, because warehouses are the ones with high or big box and retail spaces. Skylight requirements are pretty specific for those. So they try to simplify. If floor to ceiling distance, that stack aisle goes to 50% or below, you don't consider that, or you consider that in the daylit area. If it's above 50% of the ceiling height, it's considered a permanent obstruction, so you don't need to pass those areas. Which means that if there's a high partition right next to me, if the light is coming here, if it's more than 50% of the space, I don't need to consider that part of my daylit area. I don't know who's going to look into those elevations and compare plans and elevations to calculate, but it's in the code. So just to illustrate, skylit area, 70% of the window height, that's considered a skylit area. And if there's a permanent obstruction, a certain height, a certain level, if you don't pass, you're good. If you pass, you still have to calculate that as a daylit surface. Primary side lit area. In the previous or two revisions of the code, the goal used to be 15 feet. Now it's the window header height. It continues being the window header height. The biggest difference is it used to be just 2 feet in each side of the window. So to consider a daylit area, you take the size of the window and add 2 feet in each side. Now you have to add half of the window header height. So if there's a 10-foot or 10 feet high window, the daylit area would be 5 feet in each side of that window. So you're making the daylit areas much larger. And the issue with making a larger area for the daylighting zone is every fixture that it's inside of that, or even partially inside of that area, needs to have a daylighting control. So that's very important. Daylighting areas are getting bigger. So California is trying to use more and more automatic daylighting controls. That's what we can come out of this daylighting portion. So there's a primary daylit area and then a secondary daylit zone, which matches the same size. So whatever window header height is here, you repeat, that's the secondary daylit area. And it used to be primary beat skylight. Now the skylight is the mandated one. And then you go to primary and secondary. So that has been changed and adjusted in the code. So skylight always wins. And then primary and then secondary. So general lighting luminaires. So in the Seattle code is a little more challenging because if there are wall sconces in the daylit area, those wall sconces need to be dimmed or controlled by daylighting, some kind of daylighting sensor, automatic daylighting sensor. In our case in California, it's just general lighting. So all the general lighting, the fixture is partially in the skylit area or the primary, it has to be. So if 50% of that fixture is inside and the other half is illuminating another workstation, we don't care. It's considered a full-blown and controlled day leads area. And if you're thinking you don't have to worry about the secondary day lead zone, now you have. If you're doing the prescriptive method of calculation, which 85% of the engineers would use, you would have to do now first level of lighting control for primary, and then automatic day lighting control for the secondary. So if there's a 10 feet window, you go all the way 20 feet inside of the space with day lighting controls. So that might be the whole space, or open office areas with windows around those large TIs. You pretty much would have to have some kind of day lighting control, automatic day lighting control in those areas. Parking garage day lighting, I mentioned that parking garages now are, they are not, they need to follow the high-low level without automatic shut-off, except in those fixtures within the perimeter if there's some day lighting contribution. So you need to find some automatic day lighting control for those areas in the perimeter of the parking garages.
What's the deadline?
So every building that is pulling a permit starting in January 1st,
And you have to.
you have to follow depending on the size of the retrofit, and I have a couple of slides and I will cover that in 5 minutes. So that's a good point, because before there was, maybe if you're touching 50% of the fixtures, you have to do something. That number dropped to a way more relevant. So pretty much every TI is either go big or go home. You're not doing, either you touch everything or you don't touch any of those.
But it's permit activated, right?
Yes, but most of the commercial TIs, especially now with the demand response and some of the metering requirements, you will not walk away without
But
pulling
if
a
you go,
permit.
if you go into a parking garage and they have metal halides, and you want to slap in a LED, that's very non-invasive, and that doesn't occur to me that requires a
If you're pulling a permit in those parking garages, it doesn't matter if you're taking incandescent and putting LED. That's you're making the efficiency ridiculously high compared to what you have. You still have to follow the guidelines. So it's not nice, but I mean it's the same thing as an office. If there's an old office building that everything is incandescent, let's imagine that's something like that, or T12, if we might still find some, with old style ballasts, and if you're touching those fixtures, depending on the number of fixtures that you're touching, you have to follow the requirements.
But if you're just swapping out a fixture, do you have to pull a permit?
You might not have to, but in most of the times, they're trying inspectors, and you're outdoor lighting expert. What do you think in terms of?
Permit, 50% of the fixtures that you changed out requires permit. That is not considered retrofit. That's what kills us. We think of the term retrofit as gutting a 2x4. That's retrofit. This is not retrofit, it's replacement. Even if you change out 50% or more currently in an interior application, permit, Title 24, submit plans to the city. I'm an
That's
engineer,
a
I'll help
designer.
you.
He's a designer, so I mean, what I'm saying is that he would not be an advocate for that, but it's unfortunately, you have to reinforce, right? I mean, it has to, it starts from the engineering side. And believe me, that's why we had engineers kind of collapsing during those presentations, because they are not happy with that. Demand responsive controls, that's on the section 130.1E, that's brand new. And it's what's brand new is that it used to be for retail spaces, right? The big box retailer needs to have some kind of demand responsive signal, or not signal, but a zone in that space, ready for a signal from the utility company in case that happens. So it doesn't say everybody needs to follow demand response controls. You need to be pre-wired, and you have to have a dedicated zone able to drop your total lighting power by 15%. Used to be retail, and used to be a higher square footage. Now it's every single building, higher, greater than 10,000 square feet. So if I'm doing a full floor TI, that it's 10,000 square feet, I have to follow that. Which means 15% of those lighting loads need to be able to drop or to a certain level. So if I have 100%, even if I'm using 65% based on daylighting contribution and occupancy sensors, and I'm cutting the closets and taking away some of the utility spaces, they put some exemptions here. Oh, no habitable spaces do not count. So if I put all the closets out and the electrical room, no, those don't count. It has to be a permanent used space. And the lighting reduction needs to be uniform. So I cannot just turn off that full corridor that represents 15% of the space. Whatever I'm doing, I need to drop 15%. So that's doable with a relay panel, right? I can dedicate 15% of my loads to one relay in my panel, and then I receive a signal from my utility company and I turn off that relay. That's a kind of a cheap way of doing it. What we are seeing, because of uniformity requirements, you probably have to use systems like digital lighting management or the system that you saw before in the presentation, where there's some, first of all, you have continuous dimming, so you will be able to drop everything 15% continuously in that space based on some kind of network. So the utility companies and the energy code is kind of walking towards using higher level and more automated lighting control systems. What happens is the manufacturers are trying to make those systems easier to install, easier to commission, and cost effective. So there are systems out there like mine that are very, very cost effective. There's no upfront processor-based mega $40,000 initial investment and then I start bringing down with my occupancy sensors. No, I can have an intelligent occupancy sensor connected to an intelligent power pack, linked to a little backnet bridge, and they all be MSTP connected back to a building automation system, and I can drop everything 15% based on demand shared command. So manufacturers are trying to make those systems more approachable and more effective and cost effective. So because 15-year payback is not acceptable, right? I mean, they might accept, but no building user or owner would buy anything that has a 15-year payback. So systems need to be more affordable, and their manufacturers working on that. And I'll be more than happy to share the story of my product with you guys in the end. So I'm trying to keep it as neutral as possible, but I need to pay the bills too, so appreciate you listening. So does it mean that you have to have a demand response type of control? No, you just need to be pre-wired and ready for when the utility company tells it's time to do it, you would be ready to do it. So it's a pre-wire and capable system. So they're thinking of the future. 1 year from now, 2 years from now, those buildings need to be ready to receive those demand response commands.
So eventually they're going to make it mandatory.
They will make it mandatory. Everything that we saw before, measurement, verification, and all those things that were pretty in lead projects and nobody did because it was expensive, now it's starting to be mandatory. So the next level would be probably mandatory to have some kind of demand response control. Outdoor lighting controls and equipment. There are some changes in outdoor. I am no expert in outdoor lighting. There are some experts in the room. You feel free to read more about it. I think the biggest point is outdoor lighting needs to have an auto off by an astronomical time switch, and it needs to be able to control by an automatic scheduling control, time schedule. Used to be just turn off based on a photocell, right? That's what the code says. Oh, if I have a photocell, I'm good. On top of that, I need to be able to have a time clock. So photocell mandates my lights to be on at a certain time of the day, 5 o'clock, 10 o'clock, or 6 o'clock. And they could be on all night. They cannot be on all night. They have to go to an auto shut off a certain time of the day. That's what they're asking me. Except 24/7 mandated areas and some health and life safety regulations that should not be turned off. Pretty much every outdoor lighting now needs to have a photocell and an auto shut off based on a time schedule.
What's the time schedule? You have to turn off by 3 a.m.?
I don't think there's a
We just have to have the
you have to
ability.
have the ability to do it. It can be midnight, it can be 2 o'clock, it depends. I think in this case it will be a little bit of a common sense of the application. So if it's a car dealer that stays on all night, guess what? Cannot stay on all night. There are going to be some time frames that you have to turn off those
So-
patio lights.
So there's security issues around leaving lights on in places like that. I mean, if you turn the lights off on a car lot, the cars are gonna be stolen more readily, right?
Do you have any comments on that, Kenny?
That is to be seen as far as what the Energy Commission is going to do, because here's the thing, I mean, if it's a car lot, could it be stolen? Yeah, there's nothing to mandate that they have to keep them on. If it's a parking field where people can be, you know, traveling through, that's a whole different situation. Right now, they're looking at it as life safety. If a person's walking through a parking lot at 2 o'clock in the morning, they trip and fall and break their arm, then the tenant's going to be responsible for a liability case against them. So shutting off, that's going to be a fight. Car dealership, I can say shut off, maybe leave one. Right now, and just very simply, because we're going to have a whole separate class in a future time about outdoor lighting, but there's ways to get around that with dimming to certain levels also because of the codes in the city of San Diego and the county of San
Yeah,
Diego.
depending on the municipality, what I'm seeing as a manufacturer and working with a lot of outdoor exterior lighting LED manufacturers to use our sensors, high-low is becoming way more common. And then the low level with LED, it's very efficient. And as long as you maintain, again, fixture-based control, so you have your uniformity levels, and you can be able to cut by, I don't know, 80%, and you go down to 20%. I think it's more more approach if you go with a LED driver, or even, I mean, in a retrofit, I don't see that happening, but we make a dual capacitor kind of units that can be mounted in a metal halide source that could be either in a warehouse or in an outdoor parking facility that you can drop to high-low, even metal halide. Light sources that we are not able to control because there's a trigger time and you don't want to, I mean, right, everybody watched the Super Bowl and we don't want to deal with that. Nobody wants to lose their jobs on lighting controls. So having a high-low makes a big difference because you don't want to have that 15 minutes wait for the lights to kick in all over again. So I think I'm seeing more of the LED fixtures being mounted outdoor with high-low type of controls. The beauty of LED and the 0 to 10 volt drivers, that's 0 to 10 volt, you can go all the way down to 10%. Depending on the quality of the driver, you can go even lower than that. And it's still uniform enough for life safety. So if you're walking, the place is there, there's some level of lights that compared to the general lighting in the space, it's much higher anyway. And then if somebody moves in, the lights go to a certain level. So I would see more and more, and that's what the manufacturers are trying to go towards to help with specifiers. Certificates, requirements, I mean, in my experience, permits are it's going to be more and more reinforced. We've been training inspectors also. We want them to be reinforced. I know, sorry, I mean, it's not only a brand new project, a brand new building, it's extremely effective and energy efficient, and the building envelope works, everything, they follow the LEED requirements. And then for every single new building, there's maybe 9 others in the neighborhood that have very inefficient lighting and electrical systems. What the energy commissioning or the energy code or the state is trying to reinforce is how can I make those existing buildings more effective. And before I jump into remodel and retrofit, because I think it's an interesting topic, I'm just going to bring very quickly about separating electrical loads, lighting, and plug loads. So what they're asking for, it's almost separating electrical power by lighting from lighting, separate from the receptacles from plug loads. And there's a new section on plug load controllers. So now you have to measure those two separate and be able to control those two separate. So that can be a very, very lengthy topic. I'm going to just leave that chart. You feel free to read more about it. But just keep an eye, that's a tough one to meet. The one before, smart meter, great, we can follow. When you start breaking panel, you have to have one lighting panel, one plug loads type of panel. Would be a little tougher to design. That's when the engineer starts also collapsing during the presentations this week. Control receptacles, it's been out on ASHRAE and national codes. Title 24 did not have before. For every receptacle, every uncontrolled receptacle in a space. Private office, open office, reception lobby, conference room, kitchen, and copy room. For every regular receptacle, up to 6 feet apart, it has to have a controlled receptacle. So we're probably going to see rooms with less receptacles. And that needs to follow 130.1C. That was the auto shut off, which includes the mandatory occupancy sensors. And that's in the code. It's been in the ASHRAE code. I'm not seeing a lot of plug load controls being reinforced. I think it's going to start after California kicks in. ASHRAE might follow in other states, but we are usually ahead of them. So every project for new construction needs to have some kind of plug load to control 50% of the lights, or 50% of the receptacles. At least 50% should be auto-off via sensors, and as cute as my beautiful power strip with a sensor connected to it that I can mount under my desk lighting, and I have half receptacles being controlled, so I can put my desk lighting, my heater, my fan, or whatever that I want to turn on and off, and then my computer and my telephone, whatever I plug in the others. This one is not accepted anymore. So we were all happy celebrating until they told us, oh, by the way, if you can remove from the space, it doesn't comply with Title 24. So we might sell tons of those devices for retrofit solutions, but not for new construction. New construction needs to be pre-wired. So what the code is mandating, the same sensor that's controlling my general lighting now needs to control half of my receptacles in the space for my desk lighting and other appliances. So if that person that sits in that cubicle has a 1,000-watt heater under her desk, typically her desk, because the guy is the air conditioning very high. So we are not saving energy equally. So not the poor girl that's freezing in that space now would have that heater hopefully connected to a control receptacle that needs to be labeled and clearly marked. And that's going to be another discussion, because I know that people are going to call complaining that they lost all their work because they plugged the computer in the wrong receptacle. The energy code is not even mandating a different pin or anything else. It's just, it has to be clearly labeled as a controlled receptacle. And of course, if you have a fridge or a clock in the wall or a display like a TV, you don't need to have another matching receptacle controlled by it. I mean, it's just for the utility type of receptacles in those spaces. Prescriptive methods, I think 85% again of the electrical engineers follow the prescriptive method, which means you check what's allowed, so your actual lighting power based on all the lighting power densities that you use, and then you check what you calculated and you see if it complies. So that's pretty much how most of the electrical engineers do, check, check, check. Design building contractors will do the same. In that case, remember the carrots that I talked about. So what is the benefit of following the code and going beyond codes? There's a table, 140.6. It's tough to read here, but it's a nice table. It's probably the best one on the Title 24 because it's the one that gives you the lighting power adjustment factors. So it gives you extra watts per square foot to use throughout the space if you follow, for example, by level with half of the lights out or on. So if you come into a space and half of the lights turn on automatically and the other half stays off until you manually turn on, if you design like that, you get a 0.2 factor to use on your lighting power density calculation. It's almost impossible now to meet some of the energy requirements in California without following this chart. So that's taken very seriously by design build contractors and electrical engineers. A system like this that has an intelligent power pack, and I have to point because it's a genius one and it's out of the box. The way that it works is if there is a sensor, two relays, one doing, imagine this is fixture number 1 for A and B. So that's just a little demo simulating fixtures. An occupancy sensor and a 2-button switch. So that's called digital lighting management. Half of the lights automatically turn on and the other half will be manual. That's how it comes out of the box. So if the contractor is working in 100 rooms in the space and they all have an occupancy sensor, a 2-button switch, and A/B switching in that space, or even dimming. So there's a larger room controller that can do dimming for all the dimming requirement areas. Out of the box, we would only turn on half of the lights. That's how WattStopper works. If you're using a wall switch sensor that has 2 relays, you have seen that before, an occupancy sensor that has 2 relays. The way that the dip switches are configured is half of the lights turn on automatically, the other half you have to manually turn on. Most of the times people are happy with half of the lights. If you give people 2 switches in the wall, 90% of the time they would flip both switches to work in that space. If you give some level of lighting, 70% of the time people will not even touch the second one. That's why in code design there's all kinds of studies done about bi-level and out and partial one. And that's why manufacturers, instead of having a complicated commissioning system that I have to have a factory specialized field service guy to assign all the lights, we are trying to make it simple. Plug and play, and out of the box it works. If I want to make it fancy and go back to the building automation system to shed my lights by 15%, I can. But if I lose that, my room would still work by level and following all the energy rules. So that's kind of a big deal from the manufacturer's standpoint, because there are systems available now that allow you to make it very simple. There are also benefits by using more sensors. So in open office spaces with multiple cubicles, the more sensors you use to control individual areas, the higher the factor, the lighting power factor. So I go from 20% to 40%, so a 0.2 factor to a 0.4, based on the number of sensors that I'm using. Just to wrap up, alteration and modification in place. Those are the 2, this is the terminology used by the code: lighting systems alteration and modification in place. So lighting system alteration, we see that as a TI. It's a TI space, and a modification in place is a ballast retrofit. What is the rule for TI work? You're talking about, Kenny was saying 50%. If you're touching 50% now with the current Title 24, 50% of the luminaires in the space, you need to follow Title 24.